Okay, everybody, have you done that? Well done. So we found out that that is always true. Every time we take away 9, it is the same as taking away 10 and adding 1. It always gives us the same number. So that's a good strategy we can use when we want to subtract 9. We can take away 10 and add 1. So why does that happen then? So we need to make our conclusion, write down our conclusion, think about why that happens. So we might say, when we subtract 9, it is always the same as subtracting 10 and adding 1. This is because and then we could draw a number line to explain. If you take away 9, that's 9 there. It is the same as taking away 10, which is 1 more than 9, and then adding 1 back on. You get to the, oh, sorry. Let me draw that again for you so you can see. If we subtract 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, it is the same as subtracting 10, so going 1 further and then coming 1 step back again. You always get to the same place on the number line. So we can use those pictures of our representations to help us explain things as well. Using the pictures to help us explain is really, really useful. Okay, let's go on to the next one. A 2-digit number, subtract a 2-digit number, gives a 2-digit number. Does this happen always, sometimes, or never? So let's have a think about our testing criteria. I'm going to think I would like to test numbers that have a big difference. So numbers that are far away from each other on a number line, numbers that have a lot of numbers between them. Okay, numbers that have a small difference. So numbers that are close together on a number line, numbers that do not have many numbers in between them. And I think numbers that have different amounts of ones as well. So for example, 58 take away 23. So you've got numbers that have different ones. That's what I would like to test, to see if a 2-digit number, take away a 2-digit number, always gives a 2-digit number. Pause the video now, and I would like you to investigate that statement and see what you find out. Off you go. Have you done that? Well done. Now have a go at trying to explain why. If you've got somebody in your house that you can speak to about it, see if you can have a go at explaining why. If you don't, have a go and pretend talking to the computer or to a mirror, because sometimes when you talk it through to yourself first, it helps you to write it down and explain. Okay, pause the video now and have a go. Have you done that? Well done. Okay, so we should have found out that sometimes a 2-digit number, take away a 2-digit number, gives a 2-digit number. Not always, because sometimes it will give us a 1-digit number. Did you find out when that happens? Have a go at trying to explain that. You should have found out that numbers that have a small difference, so for example 79 take away 75, will actually give you a 1-digit number rather than a 2-digit number. So well done. And that's because you're taking away the same amount of 10s, so you're left with only 1s. Well done, everybody. Okay, let's go on to this one. When I subtract an even number from an even number, I get an odd number. Let's have a think about that. Let's try and remember what our even numbers are. We've got 2, 4, 6, 8, and 10. And then anything else that has these numbers as their ones digit. So 12, 14, 16, etc. Okay, I'd like you to pause the video now and I want you to come up with your testing criteria. What are you going to test to prove whether that is always, sometimes, or never true? Off you go. Okay, everybody, have you done that? So you've come up with your testing criteria for this statement. When I subtract an even number from an even number, I get an odd number. So I've come up with some testing criteria myself. I wonder if mine was similar to yours. I would like to test whether, well, I've got to test all even numbers, first of all. They've got to all be even numbers. But I want to test, first of all, a one-digit number, take away a one-digit number. So I'm going to write here, all even numbers I need to test. All of them have got to be even. There's no point me testing odd numbers because that's not the question. It's when I take away even numbers. All even numbers. And I want to test a one digit, take away another one digit to see if that gives me an odd number. I want to test two-digit numbers, take away two-digit numbers to see if that gives me an odd number. And then I want to test a two-digit number, take away a one-digit number and see if that gives me an odd number, but they've all got to be even. So for this, I want you to have a go and I want you to test that yourselves, but I would like you to use the resource file if you can get it, which is on the website. I'll show you it now and I'll give you an example. I'm going to use this, if it will let me share, hold on. There we go, which is some interactive Numicon that you can use. So I'm going to test my even numbers. So remember, I'm only using the even numbers. This 1 is an odd number, so I'm not using that. 2 is even, 3 is odd. And then I'm over on this side. Oh no, if I scroll down, I've got 4, which is even, so I could use that. 5 is odd, so I can't use that. 6 is even, so I can use that. 7 is odd, 8 is even, 9 is odd, and 10 is even. Now, do you notice that the even numbers have got, they're even because there's 2 in a row, so they don't have the sticky uppy bit. The odd ones, you can see it's odd because it's missing its friend sitting next to it. It's got a sticky uppy bit there. It's not in an equal pair. So that's odd because it has a sticky uppy bit. That's even. They're all in equal pairs. Okay, so first of all, I wanted to test my one digit and my one digit. So I'm going to test 8, take away 2. So if I take away 2 from 8, I can put that over the top if I can. There we go, bring to the front. And you'll see I can then find out the difference between 2 and 8. Okay, 8 take away 2. So 8 take away 2 equals, and I've got 6 left here, 2, 4, 6. 8 take away 2 equals 6. Is that an even number or an odd number? It's even. Okay, let's try another one. Let's try 6 take away 4. Oh, 6, take away 4. You can see that the difference there is how much I've got left, which is 2. Is that an even number or an odd number? It's even. Okay, I want you to pause the video now. I want you to open up the notebook file that's on the website, and I want you to explore that a little bit more. Test some more 1-digit numbers, take away 1-digit numbers. Test your 2-digit, take away 2 digits. Test your 2 digits, take away 1 digit, and see what you find out. Does it happen always, sometimes, or never when you take away an even number from an even number? What can you find out? If you had other testing criteria, then you will want to test that as well. You might have more testing criteria than I did, and that's absolutely fine. So pause the video now, off you go. Okay, have you had a go at investigating that? What did you find out? I found that every time I subtracted an even number from another even number, I always ended up with an even number again. Did you find the same? If you didn't, go back and just double check that you got your answers definitely correct, because I definitely found that out. Now let's have a look, because we need to try and answer why. So let's have a look at what happens when we take away an even number from an even number. If you take away an even number from an even number, every time you've got an even number to subtract, you never have one of those sticky uppy bits to take away. So you're always going to take away an even group, which will always leave you with an even group. Look, if I take away 4, I've got 2 even groups there to subtract, which leaves me with an even group. I'm never going to end up with a sticky uppy bit like I would if I took away 3. Then I've got a sticky downy bit here, which is odd. But whenever I take away the even numbers, it always ends up as even. Can you see that? So I've got to have a go at trying to write that down as a conclusion. So I would write that like this. I've got to write down what I've thought and what I found out. When I subtract an even number from an even number, the difference, remember that means the answer to the subtraction, the amount of numbers between, the difference is always even. Or you could have written is never odd, because that was the question in the first place. So now we've got to try and explain why. Because, remember, we've got to use that conjunction because that helps us to explain why. Because you start with even groups of 2, and I could even draw a picture. Remember, those pictures are really useful to help us explain. And you take away even groups. So I could use my red pen to show that I've taken away an even group. You are always left, you are always, I'm running out of space, always left with even groups. There we go. Fantastic. Okay, so now it's your chance to put all your learning into practice now and really be an investigator. So remember that success criteria. Come up with your test criteria, investigate it, write a conclusion. If you want to have a go at challenge 1, then you're investigating this statement. The weight will never balance as soon as you put weights on it. So you're going to go to this link here and have a go. You've got to think about what you're going to test. So I'm going to show you it now, although it's definitely gone away from me. Hold on. So you're going to go to the website. There we go. You're going to go to the website, and this is the balance. So the question that you're experimenting with is, as soon as you put a weight on this balance here, so let's put this weight on there, it's never going to be even again. It's never going to balance. So in order for it to be balanced, it's got to be exactly equal. So it's got to be level, okay? If you put a weight on it, it's never going to balance ever again. Okay, is that always, sometimes, or never true? You've got to think of what are you going to test? Where are you going to put your weights to test whether that's right? Then you're going to have a go and test it out and then write your conclusion, okay? If you are doing challenge 2, you're going to be investigating this statement. You can only make the weight balance if you use 2 weights on one side and 2 weights on the other side, okay? So your question to test is, it's only going to balance if you put 2 weights on this side and 2 weights on this side. Is that always, sometimes, or never true? You'd have to put another weight on there to find that out. So again, you need to think of your testing criteria first. What are you going to test? Which numbers might you put them on to test that out? And then have a go, investigate, and tell me what you found out by writing your conclusion. If you want to have a go at challenge 3, you're going to be investigating the statement, you can't have an odd number of weights on one side and an even number on the other. So if I go back to the weights, that means they're saying that you can't have, say, 3 weights on this side because that's an odd number, and an even number on the other, so say 2, because then it won't balance. So an odd number on one side and an even number on the other, number of weights. Okay, so you're going to, again, come up with your testing criteria, think about what you're going to test first, then investigate, and then write your conclusion. Try to explain why, okay? Bonus points for those of you who can really explain why. And once you've had a go at that, if you want to, there is an optional extension as well. That means you can have a go at it if you want to at the end of the lesson. You don't have to. It's if you feel that you've got time and you want to extend your thinking a little bit more. And you're going to go to this webpage and you're going to think about, you can only do this for the digits 1 to 9. You cannot find it with the number 10. So let me show you what that looks like so you understand what to do. Okay. Oh, 1 second. So this is for this one. And it says that the challenge is about finding the difference between numbers which have the same tens digit. So here 24 and 21 has the same tens digit and the difference is 3. So the circle at the top shows you the difference between the numbers at the bottom. The numbers at the bottom always have the same tens digits. And the statement that you've got to investigate is that you can only do it for the numbers 1 to 9. You can't do it for the number 10. So the circle at the top will never be able to be number 10 if the tens digits are the same. Is that always true, sometimes true, or never true? You've got to come up with your 6 testing criteria, investigate, and then write a conclusion, try and explain why. Okay, well done everybody. This is a super thinking lesson. So you've really got to do lots and lots of thinking. I can't wait to see what all your wonderful thoughts are and what you found out about subtraction as well. Well done. I can't wait to see your work. Bye.